I'm short. Let me fix my chair. Hello world and happy hacking. My name is Mark Tellez and this is webdevcourses.tv, and we are going to be doing vanilla JavaScript, but I have to get some windows open. I'm running a little bit late. My apologies. I can't actually check to see if I'm live on the other channel, so hopefully somebody will be able to tell me that is here on the team. Give me just 1 second. I got to open up a new file, new window. Hello, it's on the wrong fucking screen. All right, VS Code's driving me crazy. What is going on here? Oh, I hate VS Code on Windows. It is so much better on the Mac. Close window. Yes. No, I don't want to save it. I'm going to close it. No, close it, I said. Come on. Come on, you can close it. No? Window. Let's try this again. Open up VS Code. There we go. Sorry about that. Let's quick switch over to this screen. Oh no. How do I not have my background? Man, I'm all kinds of fucked up this morning. My apologies. We were up very late last night trying to get this stuff going, and apparently I didn't finish it. Whoa, it's yellow, man. It's yellow. There we go. That's better. So how's everybody doing? Let me just make a check real quick because nobody's telling me if we're on. Hey, you. Coffee and water. I guess we'll just give people a couple minutes to hop on, and then I'll redo the intro and we can get started. So vanilla JavaScript for beginners. Let's create a folder for this if we don't already have one. Let's see, I got web dev courses, and I should have classes. And where are my classes? Apparently I didn't create these folders. Okay, so vanilla JavaScript for beginners. Why vanilla JavaScript? Why for beginners? My shortcut to get in, that's $_ That's just going to repeat the last parameter that you gave your commands. So the yellow. Yellow's for JavaScript. I decided the background was a little bit too distracting. Solid colors are great. So vanilla JavaScript for beginners. By the way, welcome if you're on Twitch. Welcome if you're on YouTube. I'm very happy to be spending this Monday morning with you. Learning JavaScript, teaching you JavaScript. I've been doing JavaScript since 1997. All right, so let's redo this. Hello world and happy hacking. My name is Mark and I will be your instructor today at webdevcourses.tv, and this is vanilla JavaScript. Alrighty, so vanilla JavaScript. Why vanilla JavaScript? Why JavaScript? Why for beginners? Why all these things? Why? Well, I think why is probably generally a more important question than how. How is easy. How you can come up with on your own. Why takes effort and thinking and research. You got to do the reading to understand the why. Okay, so vanilla JavaScript, because whether you're writing TypeScript, whether you're writing Babel, or whether you're writing, ES 20,000, whatever it is, in the end, it still gets transpiled down into vanilla JavaScript. And if you don't know vanilla JavaScript, you're not going to have the deeper knowledge that you need for these other things. So the point of this class is to rectify that issue. Let's open up a file, shall we? Now, we could do this in the browser. We've already done a couple of days in the browser. I want to do this not necessarily on the server side, although this is going to be running with Node. So technically it's not running in a browser. It's more like a headless browser, but it doesn't have like a window object. You have a global object, but not a window object. In the browser, the window object is the global. And in Node, global is the node, or global is the global. Global is the new global. Okay, so JavaScript. We are going to look at... My notes aren't here. I wrote down notes and now I don't have them. Oh, I do. I do. I'm just hiding them from myself. Hey, I got a place to put my notes now. So yeah, let's talk about blocks. Blocks are very important in JavaScript. If you have a block, all that means is that you have curly braces. In old style JavaScript, like really old style, you would see a lot of this stuff where there were curly braces here to try to create a scope. The problem is that var is always hoisted, and so you don't ever end up getting that scope. So let's say we have foo equals bar. Pretty classic example. Doesn't mean anything. So if we were to go console.dir and we were to print out our foo, we can open up our terminal and we can run this with Node. Well, we could if I called it right. Apparently I have a dot in front of it. Why would I have a dot in front of it? Not a dot file. So if we run this, we get bar. But according to the rules of JavaScript, really we shouldn't. This is just a relic of the old days. So you'll notice if I switch it to foo, suddenly it becomes undefined. It becomes undefined because foo is defined inside of this block. And this block is going to prevent foo from going any higher than that. It still get hoisted. If you put a function here and you put, I don't know, some more vars here. And then you had some more code here. You've got an if something, if true, console.dir true, if false, console.dir false. And then we could do something like console.log foo. So if foo exists, we're going to try to console log it. Okay, we're going to have to get rid of that function because I didn't actually give it a name. I was just throwing crap in there. Okay, so this one is going to have to go because we don't have that scope anymore, right? And now we get what we would expect. Now this is not going to be hoisted up to here, and therefore it's not available to here. And you can also add use strict to this, which I think is on by default with Node. But if you're in the browser, you definitely have to add node strict to prevent or to create this sort of a thing where the hoisting is essentially fixed. Relying on hoisting is a terrible idea. Your code should be written in the way that it is going to be read. Your code should be written in the way it's going to be read for, actually, I guess I should say not false. If it's not false, we're going to print true. So we'll get two trues. That distracted me. I get distracted pretty easy. Problem with ADHD. It's sort of a superpower until it's not. Okay. So if I run this again, I'm going to get the true foo. Okay, so we know that blocks matter. Okay, a block can be like just an empty set of braces. A block can be some sort of an if statement. As long as you can type, it'll work. A block can be a function. If we change that to a function called, just log or something, we don't need to have an argument anymore. We can just call it. And it still works. If we try to put log up here, still works. This is because we're outside of the scope. This stuff will always get hoisted. It'll always be moved like that, where the functions are at the top. Now you could put the functions at the bottom in this case. I wouldn't put declarations at the bottom, but putting functions at the bottom of your file is not going to be a big problem because the code that you're actually running is going to be up here. All right, let's talk about closure for a minute. The easiest way to start with closure is to start with an efi, which you also need to learn anyway. All an efi is if you put parentheses around this, you've turned it into a functional expression with just that one little change. What is a functional expression? Well, a functional expression returns stuff, first off. So we're going to return something. Let's just return foo. So we created a foo inside of our closure, and then we're returning foo here. But if we run this code, it's not going to run. It doesn't run because we haven't called foo. Now, you could totally do, you know, or I guess log is what's called now. You could totally do this. This is what most people do. The problem here is that now it's inside of that expression, so you can't quite do that. Now, I would put these here, but ESLint or whoever is ESHint, whoever is doing that is changing it for me. But I like the dog balls tucked inside, but whatever. So now it works again. This is an efi. Why is it an efi? Because it's an immediate, well, first off, it's a functional expression. The parentheses around that function block turn it into an expression. It would be very similar as if you wrote, you know, const log equals blah, 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 you know, some function. That would also be a functional expression, but then you'd have assignment. And in this way, you don't have assignment. It's immediately invoking. That's the II of the efi, because it's put into an expression and then it's immediately called. So that's a functional expression. That's an efi. And those are blocks. Let's talk about closures. There's another way of doing closures without a functional expression. You create yourself a function. Now, some people would say that this is that if you just move this out here, that's closure. It's not closure. It might create a closure, but it's not the same thing as a closure. And the reason why is because it's all leaked out to the global space. You don't modify the global space. You especially don't modify the global space if you're trying to create a closure. So what we really need to do, move this back inside. We don't need the strict, just the let foo. Move this back inside. Let's actually make one that's more useful. Let's say that you have a callback, which we also have to discuss. You have a callback. We're going to call this function. When the function is done working, it's going to return us a callback. Let's just call it after run. So you got this thing. It's going to run. And then after it runs, we want this thing to happen. Let's give it a value. I don't know what it's going to have, but it's going to get some value. And then let's just console.log out that value. If you wonder why I use console.dir, because I can do this and I can get the equivalent of this without typing it all out. So it would be the same as if you did like a log, like so. And then you did this. And you can see why I do this, because I mistype shit all the time. So if you're mistyping stuff, you're creating errors. If I have to type the same thing twice, I'm likely not only going to make mistakes here, I'm going to make the same mistakes here. So rather than writing it like this, which I find detestful, I just prefer to write it like that. Okay, so what will happen here? Nothing, because we're not doing anything yet. Let's create another function. This one that actually creates the closure. Let's call this run CMD. Run CMD doesn't return it doesn't run the command immediately. It returns a closure that will run the command. So let's return a function. And this function is going to take some value. And let's call after run. So we're going to say, hey, we're going to run this command. What is the command? Well, let's just call it CMD. We're going to run the command. We're going to do an after run. And we're going to pass that value back. But where does this value come from? That's where the closure comes in. Our closure is going to enclose our variable and our return function. And because this value is now inside of here. We're passing it down. We're passing it through the closure. This is a value object. Value objects get stored in memory as just copies. So like if you create 5 different variables with the value 1, they're all separate copies, but they're all the same variable, but they're all separate copies. So if you change one, it won't change. Got coffee all over myself. It won't change anything else. However, as soon as you take that value and you put it down into this return function, it becomes a closure. What does that mean? Well, that means it goes from the stack, because values are stored on the stack, into the heap. Because values inside of closures are inside of objects, and objects are always on the heap. So by putting this thing on the heap, it's now not garbage collected until we clean up whatever references to this run command. All right, so how does it work? Let's do this. We're going to call that command. We're going to say that the command is hello world. We're going to set the command to hello world. And then we're going to run this on set timeout. Set timeout takes a function that it's going to call when the timeout is done. And then it takes how long it's going to be. So let's say 2 seconds. So this is also going to take after run. And you'll notice that I didn't pass the actual argument here. That's because the argument comes in down here. Okay, so what does this give us back? Well, this gives us back this, let's call it a runner. Gives you back a runner. The runner is actually what we're going to put in here, because the runner is the function that gets returned. So if you look here, run command sets a variable, and then it returns a function. And this is where the magic happens. This is why JavaScript is different than other languages. And in my opinion, it's one of the greatest languages, because it allows us dynamic programming that you can't do in C. It's very difficult in C++. You got to use pointers. Can't do it in Rust. You got to use pointers. Now all these languages run faster. None of them run on the browser though, right? So JavaScript is still the winner. Face it, 80% of the world's software is web. It's not my fault. I'm just a web developer. Okay, so if we run this now, what happens? The program doesn't immediately return. That's interesting. And then it returns 2 seconds later, and it has the thing that we put in there. What if we were going to modify it? What if after run, we were also going to give it like an index, so we could see the index change? Every time you call it, we want to increment that index, right? Okay. So we're going to need another value. It's another closure, basically. We're going to create our stack variable here, but then we're going to bring that down to here, which is going to make it a closure, which is going to move it onto the heap. So now we get a 0. What happens if we do a plus plus on that? Because plus plus is going to modify the I by adding 1 to it. We still get 0. That's interesting. What happens if we were to run it twice? Okay, so we run it once. Okay, what happens if we run it twice? It's the same variable, but it's 2 seconds apart. So we'll get one and then we'll get the other. Why did we get them at the same time? Well, we got them at the same time because they both started at, the same time. If we were to switch that and double it, now we'd get one, and then 2 seconds later, we'd get the other. But what I want you to notice is the 0 has changed to a 1, and the value is still available, even though the first function call is done. That's closure. We will go more into closure much deeper a little bit later. I'm going to rename this to closure. And I guess I'm going to have to put the blocks code back in there after the call. Okay, so we've got closure. We need blocks.js. What else do I need? I need callbacks. Well, we sort of just did a callback, but we'll do another one. The reason why the callbacks are so important is because callbacks are the native way that JavaScript handles asynchronous programming. We're also going to wrap these promises, or wrap these callbacks in a promise and then turn it into async. So callbacks is the original way. Promises were introduced in like ES16, ES15. It was around ES5, ES6 basically. We got these promises thing. Promises is like something and then dot then and dot then and dot then and dot then and then maybe a dot catch or a dot finally at the end. It's known as stream programming. And then that was supplanted by the async await command, which basically just takes the promises and like wires them up in the background so you don't have to deal with them. All right, so callback. We're going to call one do work. And we're going to have work to be done as a function. And we're going to have after work done. Now, both of these are a function. So my preference is to actually give them an empty function so that if it's called without giving a function, it's not going to explode. Although we'd probably want to then tell people like, you got to pass a function. So I'll skip that right now because otherwise it's just a bunch of extra code that we don't need. And do work. Okay, so how does a callback work? How do we know to do this thing? And then to do this thing? Well, in old JavaScript, the async await thing didn't happen. So you really couldn't do it like this and then like this, because if work to be done, let's call this a function work to be done. How about just console.dir? Because the log function is not asynchronous. It's a synchronous thing. So let's call it log. And we'll just say that we're going to pass in some string. We're going to get back a console.dir and that string. Okay, so if we were to pass this log as the work to be done, or maybe the work after to be done, I guess, would probably be better. What about this? What if we were to, let's see, the work to be done, it has to be something synchronous. What if we just like went over an array or something? Let's call that work. Work doesn't need anything, I guess. And we'll just do something like let I equals 0. Might as well put that in a for loop, I guess. So for loop, we're going to do it while I is less than 10. And then we'll do I++. And then the work to be done, which is just going to be... I guess just some more consoles, just to cheat. All right, so we're going to do some work, but it's a synchronous operation, which means that this code will just work. It's not so beautiful if it's asynchronous, which I'll show you in a minute. And this is the part that kills people with JavaScript. Okay, so do work. Takes the work function, and it also takes work to be done. Yeah, we're calling it. It also takes the after work to be done, which we're going to call log. After work to be done is supposed to take the value. So let's just turn this and say, well, if you'll notice, the let I is outside of the block scope. The block scope is right here, which means that we should be able to just access it here. So work to be done in this case is an integer, and then we just pass that here. And so then we should be able to see work to be done. This would be callbacks. And we got an error. What's the error? I is not defined. Okay, fine, whatever. We are going to do closure. We're going to say const j equals, actually that has to be a let too. So let j. And then let's just say, instead of a console log, j equals I. And we'll just return j. Alrighty. So we get a string back of 9 because we walked up to, but not including 10. Of course, if we wanted to include 10, we could just modify that. We get 10. So how does this work? Well, it's just two functions that we pass into a third function. Then we call that third function. It will force the first task to get fired. Because it's synchronous, it's going to automatically not do anything until this function has returned. Will be returned with this value I, and then we'll call after work to be done, which just passes the value. And if you look down at the function, all it does is log. So what this means, you could pass any function into this, and it'll run, and it'll return the value. And you could pass any function into this, and as long as it takes that one value, it's good. As long as it has an interface, as long as the two pieces match up, the caller and the receiver, as long as those interfaces, which are the arguments and the returns, as long as they match up, then it's like Legos, man. They just snap together. Okay, so this is a callback. And this leads to callback hell, where callbacks call other callbacks. You don't really know when they're going to come back to you. You're just like, okay, let's see. Make the call. What order are they going to come back? I don't know. Is there an order? No, it's completely a race condition. So how do you prevent the race conditions in JavaScript? How do you get rid of callback hell? And the answer is promises, but first we have to actually change this to something that is asynchronous so we can see what happens. Shit, I can't just put an async on it. Let's do a timeout. We're going to call set timeout. We're going to do work to be done only after the timeout has happened. After the work is to be done, we also want to do the after work. So this one's going to take 3,000 seconds to, well, 3,000 microseconds to do, which is 3 seconds. And let's see, after work to be done, there is no I anymore. Work to be done is going to be still sending it back. So let I work to be done, I equals. Then we get back our I, and then we're going to call this, but there's a problem. We call this, we get back an undefined immediately, and then the program pauses, and then the program comes back. But we got the after work at the wrong time. This is the problem with asynchronous operations. So what do you do? Well, the fix right here, since we know that these two things are synchronous, is you could do something like this. Now it'll wait, and then you'll get back to your defined string, which has, 9, whatever, because we went up to 9. Okay, so that's one way of fixing it. What's another way of fixing it? Well, what are we returning here in do work? We're not returning anything. It's just a procedure. It's calling some stuff. It's not returning anything. It's just doing work. Okay, how would we turn this into something that could be waited on, essentially? Like call do work and then wait until it's done to do the log. Okay, well, what you want are promises. And you don't have to require anything in the new versions of JavaScript. In the old days, you had to require Bluebird or some other promise factory. Nowadays, it's just built in. So how do you create a promise? How do you return a promise? Well, you just return a new promise. The new promise has to have a function that has two arguments, resolve and reject. Obviously, one is going to be called if things are like the golden path, and one of them is going to be called if things go horribly, horribly awry. So we just move that inside of there. Okay. So what's the resolve? What's the reject? I don't see anything that would be rejected here, but I do see a resolve. The resolve would be after this work is to be done. That's the resolve. So if we do this thing, when we finally get around to here, that's when we're going to get back our promise. And there is no reject in this case, so I'll just leave that off. How does this change things? Well, we'd have to do something like this. We'd say const e equals, this is our promise. We call it, and then we can get back this dot then thing. In fact, we don't even need the assignment because this returns the promise. So when we do a dot at the end of this, we're getting back the promise. Okay, so what does the promise give you back? Well, what does it resolve? It resolves the work after work to be done, which in our case is just an I. So let's do console.log work done. And I guess we can just do a plus I. So now the program waits and we get back, we got undefined, but we did get work done and we did get our string back. Okay. So why did it say work done undefined? Here's our I, right? We're passing it back. We're sending it into here. Oh, we're not. Resolve after work done doesn't return anything. Right? It just console logs out a string. This is something that you're going to have to be careful with when you start writing stuff and you don't write it in a functional manner. If everything returns, like, you just don't have a problem. But when things stop returning, suddenly you've got like data that's missing and you don't know why, and you have to dig through your code to find. I say just return. Like, you should always have a return value. I honestly don't see any reason why a return value should be omitted ever. Even if what you do is a procedure, still it's doing something. Why don't you return some sort of a status to let people know like what this thing did? If you get in the habit of always returning something, you'll find that your fight with nulls and undefines will go away. And also don't use null. Okay, what are we doing on time? We're doing good. So this is callbacks. And now it's been turned into promises. So let me just undo this back to where it was. Right there. Now let's create promises. And we'll do chat after we get through this, and probably about 15 minutes, maybe 10 minutes. Okay. And finally, we have async await, which I didn't even put in my list. But you can't really discuss promises and callbacks without async await, because this is the way that things work these days. So let's just take our promises and let's bring it into async await. And let's see, what does it take to go from promises to async await? All it takes is we're going to get rid of this stuff. We don't do that anymore. Instead, we await the return of it and we get back the thing. So what are we getting back? Well, we're getting back this return promise. Okay. When that comes back, what do we get? Oh, well, we get the resolve, which is the work after done, which returns a variable, right? So const I equals await do work log. We have to add async here because it's now an asynchronous function. And let's see, is work asynchronous? It's not. So we don't have to add async there. So let's run our thing on async await. Await is only available at the top level of bodies of modules. Now this is going to change in new versions of Node, but it hasn't changed yet. So what's the fix? The fix is an efi. So we're just going to create ourselves an anonymous function. We're going to put our dog balls on. We're going to paste our stuff in, run the same command. It's going to tell us that await is only available in async function. So you just add an async up here. Your job is done. And now you have an asynchronous await function. I will commit all this code and I will push it. Let me put the blocks back in. So if you have a var I equals 0 and you put in a block and you say console.dir I, you're fine. If you then do the same thing with a j, we print off a j. Let's run our code. We get I is 1 and j, or I is 0 and j is 1, which is exactly what we expect. We then put use strict in, but that's going to get hoisted to the top, I'm pretty sure. Actually, I have to put it in the top, otherwise I'm going to get those funky parentheses. Actually, I have to keep that strict out or it's going to screw up the whole file. Then we do the same thing with let. Let I equals 0. Const I. Works fine. Let's move JJ in here. And let's move the console out. Run our file, and now we get an error because of closure, or because of block scope. Excellent. Let me add all this. Git add dot git commit dash m. I have to use the restroom. I'll be right back. Sorry about that. Alrighty. So we showed blocks. We're committing our code. Let's call this blocks, closures, callbacks, promises, and async. What do you mean it's not a Git story? Okay, well now it is. Let's create, gotta be careful about these screens. Don't want to be showing my developer keys or my IP addresses or anything else that'll get me in trouble. So we're going to switch over to webdevcourses.tv or webdevcourses TV on GitHub, right? So webdevcourses TV, and we're going to create a new repository. And we're going to call this JavaScript 101. Let's call it vanilla JavaScript. Vanilla JavaScript 101. And then, should I keep putting, yeah, I'll put them all in the same thing. Make it public. Create repository. And let's see, we need to do get remote, add origin. Get remote, add origin. Why is it doing that twice? I guess because I typed it and then I copied it too. All right, so we've got a new origin. I'll just move the branch to main, otherwise I'll get canceled. The thing about this stuff, man, if you don't conform, if you don't comply, you're done. All right, complied. Thank you. My compliance is accepted, right? You're not going to try to ban all my videos. I've had my JSON videos flagged and removed from my other channel. JSON, right? Like code. Why? It was overtly political, apparently. The internet's crazy, people. You got to watch yourself. You got to watch yourself for the weirdos that are looking for your real address. And then you also got to watch yourself from the weirdos that just like flag stuff for no reason. Like, this is a programming channel, man. Alrighty, so we got vanilla JavaScript for beginners. We've got our branch push. We've got our files named. I said it's good enough for right now. I'll add a README later. If you guys want to fork this project, add a README, do whatever, I invite you to. Like, this code will get better if we all work on it together. That's kind of my theory here. So yeah, that was vanilla JavaScript 101, JS for beginners. We did blocks, we did closure, we did callbacks, we did promises. Let me see if I can find my peeps here on YouTube. I got to go here. Might have to take that off the screen for a minute. Give me just a minute. I want to say hi to people on Twitch and on YouTube. They make it incredibly hard to get to. Okay, so there's the YouTube side of things. And I'll come to Twitch here in just a second. Yo, yeah, had the wife work on my hair a little bit. I'm gonna let her play. We're gonna try to be stylistic here. She can do whatever she wants to my hair. She wants to put it in silly braids. If she wants to paint it colors, like whatever. So Mayank, what's up, buddy? Thank you for stopping by and saying hi. Josh, always a pleasure. Thank you. Northern Chimp, one of my generals. Josh, actually all three of those guys are my generals. By the way, Mayank, how have you been faring over there in India? I haven't seen any bumps to the channel from India, so I don't think that you've been spreading the word very far yet, but I know you will. Also, Josh, make sure I know what city you're in currently. I think I know. You don't have to put it on the chat, obviously. Make sure I know where you're at. So, like, if I see traffic from you from your local area, I can attribute to you. Same thing with you, Northern Chip. I know you're over in Europe somewhere. I think you're stuck in France. No, that was another guy. Maybe it's you. Puneet. Well, also, like, I think she was going for a bit of, like, what's his name from Pix Imperfect? Umesh? I don't have that beautiful Umesh hair. I love Umesh. If you guys want to learn Photoshop, you really need to watch Pix Imperfect. Umesh is fucking amazing. I love him. What's up, Chris? We got another general. Welcome to the channel. Welcome everybody who I haven't called a general. I'm sorry. I'm not trying to not include you, but to be a general, all you got to do is like hang out on Twitch or on Twitter. Not Twitter. Twitch or on YouTube during the live streams and participate, and I will gladly invite you to the generals. Let's see. Where am I supposed to be going to? Here, I think. Hopefully I don't show any keys or anything. I'm not a very good Twitcher yet. I don't really understand Twitch yet. Twitch is empty. We got 3 viewers on, but nobody said hi. So I'll start first. Hi, Twitch. How y'all doing? Welcome to Web Dev Courses TV. My name is Mark. For those of you who don't know me, I've been doing web development for 25 years. I started like in 1995 doing HTML and CSS, and then I got completely hooked. 1996 rolled around, was just like, I lived on Angel Fire and GeoCities, well, and Warcraft and some other things. But I lived on that shit. I was at coffee shops every single day. Well, not coffee shops. We would call them cyber cafes. I worked deals with the cyber cafe to give me free time at the cyber cafe because I didn't have a computer. I was a homeless kid. And so I would sit at the library on these computers or sit at the cyber cafes on these computers, and I would just code. And then JavaScript came along, and, well, I started working with it in 97, and I swear to you, my whole life changed. I became a programmer. I could now afford, a cheap hotel room at night so that, like, I didn't get robbed in my sleep. I didn't get, like, rained on or whatever. It was a complete change in my life. So all those people that are just struggling to get started in this, keep with it, stick with it. It pays off. Having programming skills is probably the biggest equalizer in today's world, because you can be anywhere. You can speak any language. If you can code, you can find work. Now, it's harder to find work if you can code, but you don't speak good English. I understand that. You'll have to look in a market where your language is the primary language, maybe, but even here in Mexico, all the developers write their code in English, and most of the conversations at the companies about technology is in English, and then like all the other stuff is Spanish. So there are places, you just have to look around. Anthony GG, what's up? It's my Go buddy. If you want to learn Go, and you should at least familiarize yourself with Go so that you at least understand like the philosophy of Go, what Go code looks like, how it differs from other languages. If you can just answer those simple questions, which you could find all by hanging out with Anthony GG on his I think he's got a Twitch channel too. I know he has a YouTube channel. That's where I found him. He's the guy to go to. So it is coming up on time, my friends. I have to get ready for the next stream. The next stream is going to be, we're starting a pie business, apparently. I did a poll, and Cherry Pie Shop is the one that won. So we're building a Cherry Pie Shop. So next we got designing user interfaces using Tailwind CSS. Actually, is that correct? Let me just make sure. If you guys go to webdevcourses.tv, you will find the schedule, and you'll also find some about information about the show. I'm still working on this stuff. I want to shout out big, huge thanks to Chris Loggins, who helped me work on this when I didn't have time. So the schedule for this week, 10 a.m. vanilla JavaScript for absolute beginners, which is what we just did. 11 a.m. designing user interfaces using Tailwind. Even if you're not a designer, this is super, super important. That's why it's for developers. You have to be able to at least do a little bit of design, just enough so that your stuff doesn't look like total garbage. A designer should be able to give you something, and then you should be able to replicate that in HTML and CSS. At 12 p.m., we're doing introduction to web development, introduction to modern web development. Here's what we're doing. We're starting over on all this because I want to take this pie shop thing that people like, and we're going to use this a couple of times. So we're going to be using the pie shop for designing user interface with Tailwind CSS. We're going to be doing a We Love Cherry Pies logo, and we're going to be building out the cherry pie detail page for the product, right? So you're looking at a product, it's a type of cherry pie, there's options, there's shipping, there's all of that stuff. That's what we're going to be working on at the 11 a.m. At the 12 p.m., remember, these are all Mexico times. At 12 p.m., introduction to modern web development, we're going to be spinning up React, we're going to be spinning up nextjs, we're going to be spinning up Tailwind CSS, and we're going to start building the actual details page and put the logo on, and we're going to start building the stuff that we designed out in the design section, right? We'll be using Photoshop and HTML, CSS, and Tailwind. 7 p.m., we come back for databases and CRUD after a break. 7 p.m. Mexico City time tonight, MongoDB. We're going to be building out the database for the Pie Shop. Finally, 8 p.m., learn JavaScript by building a web RPG game. Now, this is awesome. This is a top-down game like a JRPG or the old Pokemon-style games on like the SE and the S. Or think like NES and Homeworld. We're going to be building these sorts of games. Final Fantasy, another one. We're going to be building that sort of a game. We've already got the graphics. We've already got that stuff settled. We've already got the background. We're going to get the Bobby guy to move around the screen. So that should be great fun. That's at 8 p.m. tonight. We probably go 2 hours on that. So thank you for watching WebDevCourses.tv. My name is Mark, and I welcome you to the next show, which is Designing User Interfaces Using Tailwind CSS.